Hi everybody, just coming back to you for some more information about matrices, their uses, things like that. Looking at this section in this week, which is week 5, looking at how we can use matrices to help us solve systems of equations. So let's take a look down here at this system of equations. Remember, that is multiple equations representing the same solutions. Normally, if I were solving this system of equations, I would solve it with substitution. I'd isolate the variable and then plug in. But we also learned, aside from substitution to solve equations, that you also could solve by graphing and looking for where the lines intersect. You also could solve by elimination, which was trying to get similar coefficients and then eliminating a variable. But a fourth option, okay, not as common, but it is just a good way to realize we have different ways to solve things, is to create a matrix equation, putting matrices into the mix. And if I were going to do that, I'm going to create a matrix that has a coefficient, a variable, and a constant matrix. It would look something like this. 1, 2, 3, 5. Here is my coefficient matrix times my variable matrix. Well, I have x's and y's. And I would set that equal to my constant matrix, which was 5 and 14. So from a system of equations, we can create a matrix equation, just putting matrices into the mix. And then I could work to solve this. If I wanted to solve for this, that means I want to isolate that matrix. And if I want to isolate that matrix, I'm going to call this matrix A, then I need to take the inverse of it. And if I multiply one side by the inverse, what I do to one side, I have to do to the other side as well. And that's how we could work to solve it, aside from substitution. All right, so let's actually go through and solve one of these then. Again, I would create 5, 3, 3.
Hi, everybody.
Mr. Fitch says hi, everybody.
Oh, that looks gross.
And then we would create, he's annoying sometimes, but I love him. All right, anyways, we also would have our coefficient matrix equal to our, sorry, let me rephrase now that he's gone. All right, we got coefficient matrix, variable matrix, and our constant matrix. All right, working to solve, I need to find, I'm going to use a different color, I need to find the inverse of our coefficient matrix. First, I need to determine, does it even have an inverse? So the determinant of this is going to equal, remember, diagonal subtracted, 10 minus 9, which is 1. Hey, as long as the determinant's any number other than 0, yes, we have an inverse. And I'm going to call this A, just so we can refer to it. So the inverse of matrix A is going to be, remember, we take the reciprocal of our determinant, and we multiply it by a new matrix that we're creating. And our new matrix here, remember, we switch these spots in the diagonal, first diagonal, and then we switch the signs in the second one. And then I can distribute this in. Well, hey, there's really no need to distribute a 1 to anything. So we could say that the inverse is 2, -3, -3, 5. That is the inverse of matrix A. We did that so that we could multiply in order to cancel them out and get our identity matrix. But what I do to one side, I'm going to do to the other side as well. So now I need to take this inverse and multiply it by the constant matrix. Notice, and just double check, this is a 2 by 2 times 2 by 1. Hey, I can multiply these because these are equal. Therefore, my resulting answer will be a 2-row by 1-column matrix. Oops, let me slide that up some more then. And then finally, multiplying this out, well, I'm going to have 14 plus a -15 will give me a -1. And then for row 2, I'm going to have a -21 plus 25 will give me 4. Therefore, I have now isolated the the variable matrix by itself. It is equal to this, which we can now say then that A is -1 and B is 4. We have solved the system of equations. Remember, if you ever wanted to check, if you had lots of time, you could always plug back in to check. Okay? All right, so that is solving a matrix equation. You created matrices in order to find the inverses and isolate the variable matrix. All right, I'm gonna try this one. Take a minute, see if you can do it. I'm just gonna kind of work through quietly, and then I'll just kind of double check and see if we're right. You can always pause my videos, by the way, if you need to check them on your own or rewatch anything. Add an inverse. I need scratch paper here for a second. Hopefully you've got a calculator, but I'm going to be working out, looks like negative 44 sevenths plus, looks like negative 2 to me. And 8. And I've got my solution. Well, let's not circle that, sorry. Let me put that equal to this. And therefore we could say that the solution to the system, if I were just solving a matrix equation, I could stop here and leave my answer as a matrix. But remember, it's actually solving a system. And anytime you're looking for a system, you're really looking for the point. And so here's the point of intersection, and I want to express it as a point. We always put our stuff in alphabetical order. All right, so hopefully you kind of followed along and you were able to do that. Feel free to, again, pause it as you go. But there would be solving a system of 2 equations. So you've got 2 examples to work on that way. If you were doing this same idea, you had a system of equations with 3 equations, you could still write it into a matrix equation, but then you're going to use your calculator. Remember, anything larger than a 2 by 2, a 3 by 3 or higher, you're using a calculator to go ahead and solve. And that's just typing it in and finding inverses and multiplying both sides by the inverse. Okay, so that is, we've created matrix equations and then we solved them using inverses, what we had been working on really. Another way to solve a system. So now I'm going to kind of write this in. Ways to solve systems. Okay, from algebra we learn solving systems by graphing. We learn solving systems by substitution, which is probably our preferred method. We solved by elimination, solving systems by getting similar coefficients and eliminating a variable in order to solve. We then solved just a second ago with matrix equations. And so now we're really on a 5th way to solve a system, which is with Cramer's rule. We will talk about the other way, which is augmented matrices in row echelon and reduced row echelon form, coming up in our next couple weeks. But we're going to work on another way to solve is Cramer's rule. Honestly, I think Cramer's rule is probably the easiest and the least amount of work. A lot of you could do most of this in your head. But Cramer's rule is named obviously after who found it, but really it would be nicer if it was just called the determinants rule, because it's all about using determinants to help you. And so kind of take a minute. This slide would have popped up in class and I would have let you copy it down or look at it if you want. But what this is saying is that if you have a system of equations like you see over here, then we can use determinants or a pattern to help us here. And so it says, really find the determinant of the coefficient matrix. Notice I took my coefficients, created a matrix, and I would find the determinant, and it's going to be some number, okay? And then it says, okay, now set that information aside. You're going to use that in a moment, but now go and take that same matrix, but replace the x coefficient. So instead of a and c here, replace them with the constant values. So I put those in for x's, and now find the determinant of this new matrix. You'll get a number. Remember, determinants are cross multiplying and subtracting. And then lastly, now you're going to take your same matrix. Now you've got the x's back where they go, but let's replace the y value. So instead of b and d, let's put in the constants there, and then we're going to find the determinant of that, and that'll be a number. So you really have three different numbers. Once you have those numbers, the solution to the system of equations, rather than doing matrix equations to solve, the x value is just taking this divided by this, okay, or dx over d. And then to find the y value, it's the determinant of y divided by the d value. Once you've got those two values, you put them as a point and you're done. So this is very quick and easy. It's just numerical values that we are solving for. All right, so let's go to it. Maybe I can put this, I can, kind of here so that you can kind of still see our rules. And so if I wanted to solve this, let me see if this was one of the ones that we did. No, but it was kind of close. Okay. Anyways, using Cramer's rule to solve this system. Again, I could solve this by graphing and find where the points intersect. I could solve by substitution, by elimination, by matrix equations. We're just going to say that, hey, we think Cramer's rule might be easier, and I want to try that. So I'm going to set up 3. Let's do this. I'll do it in red like we did on the last one. I'm going to take and make a matrix with just my coefficient values, and I'm going to find the determinant of that. 9 minus 2 is 7. Set it aside. And then I'm going to go do my matrix where I replace the x values. So I'm going to leave the 1 and 3 for the y coefficients alone, but I'm going to replace the x coefficients with the 5 and the 8, and I'm going to find their determinant, which would be 15 minus 8 is 7. Set it aside. Last but not least, I'm going to make a matrix where I replace not the x's, but I replace the y values with 5 and 8, and I leave the 3 and the 2 alone. Cross multiply, 24 minus 10 is 14. Once I have those values, then all I need to do to finalize the problem is that x is going to be dx divided by d, and y will equal dy over d. All right, so here I'm going to do 7 divided by 7 is 1. And here I'm going to do 14 divided by 7 is 2. My final solution to this system of equations is the point 1, 2. Now again, guys, I know a lot of you, you're like, why would I ever do this? Why would I not just solve this by substitution? Okay. It's just understanding that there are options and patterns in math that can be found and discovered. You can always check these by plugging back in to see if you're correct if you have time. All right, so we'll do one more. I'll kind of do this one quicker for you. And so looking here, I would say, all right, I'm going to say 7, negative 4, 3, 6. You don't have to listen to me. Try it on your own if you can do this. So 42. All right, so this would be 90 minus negative 32. I think that's right. Did I do that right? 90 minus Good. Okay, set that aside. Make my new matrix where I leave the x coefficients alone, but I change the y's. All right, got my 3 values. Once I have those, I'm just double checking. All right, and then I'm ready to say that x is going to equal 112 over 54, which I'm going to reduce down to, what does that reduce down to? 61 and 27. Does that seem right? That is not right. I can't do my math. What would that be? 50. How many if I'm doing my math right here, guys? That's right, 56, right? Which, hey, can that be done anymore? I'm gonna come back. Sorry, I got my kids that are trying to at the moment. Stay out, guys. Hold on, I'll be, sorry. I've shut them out of my house for a minute, but, all right, and then dy would be this over 54, which that one cannot be reduced anymore. I don't think that can either. I'm gonna leave it. I should have grabbed my calculator. Double check. Let me get to there. So this would be a messier solution. I will double check and make sure that it is not wrong in a minute here. But there we go. Remember, most things in math, especially in my class, I don't like nice, neat answers on any type of assessment. But all right, so that would use Cramer's rule to solve a system of equations. Okay, it's just using determinants rather than matrix equations and inverses. If you were doing this with a 3x3, just showing you again, you would be using a calculator to solve this. Okay, remember you would be doing, this is what you would be typing into your calculator. -2, 8, 2, -6, 0, 2, since I don't have a y value there. -7, -5, 1. This would be the first one that you would type in and then find the determinant of. Then you would do the same thing. But now you're going to have 3 solutions. You're going to have to do it for, and I'd have to come down here, z as well. Okay, and so just remember then when you were doing it, you would do 8, 2, 0, 2, -5, 1, but you would be switching the x's, 3, 1, 2, find the determinant. This one, -3, 1, 2, and then putting back in and then you would do the same thing here for z. Okay, but you change for z the last coefficients. So let me at least write these out for you, but then this would be all calculator work to help you solve. And then take this divided by this divided by this, and dz divided by d. Okay, and then you just remember you're going to write them as a point for the solution to the system. All right, then your work for the week is going to be the attached worksheet on Classroom. Please work on those problems. Again, if you wanted to do the evens as well, you could, but these ones need to be submitted to me by by Sunday the 26th. Okay, hope you're all doing well. I really do miss you, and I really wish we could be back in the classroom to do all of this stuff. Stay healthy, reach out, keep asking questions as you have them. Take care. Bye-bye.